To review exponents, just so we remember, 2 to the third is equal to 2 times 2 times 2, which is 8. 2 squared is equal to 2 times 2, which is 4. 2 to the first then would be 2, because you just have 1, 2. It's the 0 that really messes with people. So if you look at the pattern going down here, how did you go from 8 to 4? You divided by 2. How did you go from 4 to 2? You divided by 2. So how are you going to go to the next number? You're going to divide by 2, and you get 1. Anything to the 0 power is 1. And so now I go on, and of course, I'm still going to divide by 2, so it would be 1/2, and that's what 2 to the negative first is. It's 1 over 2 to the first power. Same as dividing by 2 again, you would get 1/4, which is the same as 1 over 2 to the second power. In other words, the negative exponent does not make it negative. It simply flips things from the numerator to the denominator or denominator to numerator. So of course then you're going to have 1/8, which was that 1 over 2 to the third power. So just to review some other rules that we have here, m to the third times m to the fifth. Well, that's the same base, an m, so it's still an m. I don't have 3 of them and I don't have 5 of them. I have now 8 of them. If you're multiplying exponents of the same base, you simply add the exponents. Same thing with this. Some people want to take that 3 times 3 and make it a 9, but that's saying I have 4 3's and I have 7 3's, so the base is the same. I have 11 3's. Now that would change if it were this, 3m to the fourth times 2m to the sixth. Now the 3 and the 2 are no longer bases, right? They're coefficients, so I would go ahead and multiply those, and it would still be 6m to the eighth. Next one is a power of a product. I have 2 different things, so it's kind of like the distributive property. Each thing needs to go to the 5th power that's inside that parenthesis, because the 5th power is actually touching the parenthesis. So there's an understood first power here and an understood first power here. So 4 to the 5th power, g to the 5th power. Next one is called a quotient of powers. We're dividing. Once again, you need to look at the 12 and the 10. Are they bases or are they coefficients? They're coefficients, and so we simplify them just like we simplify any fraction. I can divide out a 2 from both of them, and it's going to become 6/5. If you think about what this b to the 7th and b to the 4th is, I have 7 b's on top and 4 b's on the bottom, so I can simply subtract. 7 minus 4 is 3, so I would have 6 b to the third. Since I had more on the top, I end up with some left over on the top when they cancel each other out. The next one is a power of a product and also power of powers. Remember, the 5 is to the first power, so then I would take it to everything inside that parenthesis. So that would be 5 to the 4th, and then power to a power. If I have b to the 3rd to the 4th, I multiply those. So that'd be b to the 12th and m to the 8th. So now let's go on to the problem. So here we go. I have now a longer, more kind of detailed problem. So what I would suggest you do is set up a couple different bars out to the side so we can go ahead and simplify this thing in stages. I tend to do the parentheses, get rid of the parentheses first. So I'm going to look at that and I'm going to say, well, I would have to remember to take that power to everything inside there. And then, of course, a power to a power I multiply. So that first one would be f to the 4th. And then I have a p to the negative 10th, which I know that a negative is going to flip it from top to bottom or bottom to top. So I'm going to go ahead and put it down there as a p to the 10th on the bottom, and then a g to the 18th, which of course stays on top. All I've done is take care of this section right there. Okay. I also have a 2 on the top and a 14 on the bottom. Those are coefficients, so I could simplify them down to a 1 and a 7. Remember, they're just coefficients. Don't have to deal with any sort of an exponent rule on those at all. I also have a p to the 7th over here, which of course will be a p to the 7th on the bottom. Eventually I'm going to get that p to the 10th and p to the 7th together and make that a p to the 17th. Taking care of everything on the top, so let's go to the bottom. I already simplified the 14. I have another p to the 10th on the bottom. Once again, all those p's are eventually going to end up together. I have a g to the negative 5th, which of course once again will make it go to the top. I have an f to the negative 8th, which will make it go to the top. And I have a p to the 6th, which will stay on the bottom. Now I can go ahead and get my f's with my f's and my g's with my g's. So I'm going to set that up. I meant to get something that would simplify here. I didn't end up with anything that would simplify. So, of course, I don't have to write the 1 because anything times itself is just going to be that 1. That's its identity. So f to the 12th, when I add these two right here. G to the 23rd, when I add these two, because remember, same base, so I add the exponents. I still have a 7 on the bottom that I need to deal with. And then all of these p's go together, so I end up with 6, 16, 23, 33. So p to the, what did I say, 33? So there it is simplified.